Welcome students. Today we will learn about the sequential logic circuit. In previous class we learned about the combinational logic circuit, and today our lecture is sequential logic circuit. So these are the contents of our today lecture: introduction to sequential circuits, type of the sequential circuit, latches, flip-flops, difference between latch and flip-flops, RS flip-flop, JK flip-flop and D flip-flop. Now, that is the definition of the sequential logic circuit. Sequential logic circuit is a type of the logic circuit whose output depends not only on the present value of its input signal but on the sequence of past inputs. So, the sequential circuits use current input variables and previous input variable by storing the information and putting back into the circuit on next clock cycles. So, we can say that in the sequential logic circuits, the outputs depend the present and previous input variable values or input signal values. Now, this is the block diagrams of the sequential logic circuit. Here basically we also can say that sequential logic circuit is a combinational circuit with having the memory, and this type of the circuit basically have the memory storage and feedback mechanism. So here mention a combinational circuit having the memory, and the output portions is again used as a feedback in input form. So due to this reason, this is known as a sequential circuit. Here we give two input. One is first is the current input and second is the previous state input, and so our output basically depends on these two input, current input and previous input. So this block diagram basically introduce about the sequential circuit mechanism. Now again, sequential circuit is classified in two categories. First one is synchronous circuit and second one is asynchronous sequential circuit. The synchronous circuit, in synchronous sequential circuit, the state of device change at discrete time in response to the clock signals. In sequential circuit, the input are pulses with the certain restrictions on pulse width and propagation delays. Again, synchronous circuit is classified in two categories: clock sequential circuit and unclocked sequential circuit. In the clock sequential circuit, the clock sequential circuit have flip-flop and gated latch for its memory elements. There is a periodic clock connections to the clock input of all memory elements of the circuit to synchronize all the internal changes of states. Hence, we can say the operation of the circuit is controlled and synchronized by the periodic pulses of the clock. Next is unclocked sequential circuit. An unclocked sequential circuit required two consecutive transitions between 0 and 1 to alter the state of the circuit. So basically there is only two sequential or consecutive transactions between 0 and 1. An unclocked mode circuit is designed to respond to the pulses of the certain duration which not affect the circuit behavior. Next is asynchronous circuit. Asynchronous circuits does not have the clock signals to synchronize its internal changes of state. Hence, we can say the state change occur in direct response to the change that occur in primary input lines. An asynchronous circuit does not require the precise timing control from flip-flops. That is the block diagram of the asynchronous circuit. There is no any memory element here, and that is output is used as a feedback as a input. Asynchronous logic is more difficult to design and it has some problem compared to synchronous logic. Asynchronous circuits are used in critical parts of the synchronous system. Now, our next topic is latch and flip-flop. So, the first we have to consider the basic concept about the latch and flip-flops. Basically, we use the similar terms, or we also can say that is the synonymous the latch and flip-flop, but there is a minor changes between latches and flip-flops. The latches are basically storage element that operate with signal levels. Latches are level sensitive devices and latches are useful for design the asynchronous sequential circuit, while the flip-flops are building block of or build up with the help of the latches. And in other words, we can say latches are the building block of the flip-flops, and flip-flops are basically work on the principle of edge triggered, and due to this reason we also called the flip-flop as a edge triggered devices. There are some basic differences between latch and flip-flop. First one, latch are basically built with help of the gates. So we can say the gates are the building blocks of the latches and latches are the building block of flip-flops. The second point is that latches does not have clock signals while flip-flop has clock signals. In the latches, it is a level trigger device. It means output of the present state and input of next state depends on the level, that is binary input 0 or 1. While in the case of the flip-flop, it is as triggered device. It means output and next state input change when there is change in the clock pulse. It means when he goes positive and negative, then there make some changes. Now we consider RS flip-flop. Basically, RS flip-flop is also known as a reset set flip-flop. There is an implementation of a RS flip-flop with NAND gates, and when we use the values of R and S, then we get two output Q and Q bar. So this output results basically depends the values of the input result S and R. S and R. So if we take the value of R1 and S0, then we get value 0, 1, and in this case we call that it is a reset state. When we get the value of R0 and S1, then we get 1, 0, the value of Q and Q bar. So this state is known as a set state. And when we give the both value of R and S high, it means 1, then the result is find out the previous result. It means if we are getting the 1, 1 after values of R1 and S0, then we will give 0, 1, and if we are putting the 1, 1 out just after value of R0 and S1, then we are getting 1, 0. So at the case of the 1, 1, we basically get the previous state. And when both inputs are 0, R0 and S0, then in such a case it is invalid states. It means we don't find out proper state of what is the 1, 1. If both our inputs are 1, then how we can get 1, 1, because output is Q and Q bar. So when we get 1, 1, in such a case we provide such type of the state as a invalid state. So here we also can express this operation step by step. The combination of R1 and S0 serves to reset Q to 0 respect to the previous state of latch. The combination of R0 and S1 serves to reset Q to 1 respect of previous state of the latch. So in short and sweet, we can say the value of R1 and S0 latch gets reset state to 0, and at the case of the R, we also can say when in case of R is high, we can say that state is reset state or reset case. When we get R value 0 and S value 1, then let's get set to 1, and in this case we call this case like as a set case or set state. Now our next flip flop is JK flip flop. Basically in JK flip flop we also use the RS flip flops, and we use an additional clock circuit with this RS or flip flop or RS flip flops. When the clock signals is low, in this case we can get the two table of this. When there is no any clock, it means our clock signal is not high, it means low, then in such a case any value of J and K, there is no any next state is find out, it means there is no any variation in latch, so we finally get the latch. When we get the trigger value high, it means clock signal 1. In the case of J0 and K1, then we get the present state 0, 1, and next state same like as a present state. And similarly again we give J value 0, K value 0, and input signal is high. In this case we get 1 present state 1, 0, and next state again 1, 0. So at the case of 0, 0, both J and K are 0. In this case there is no any change in the states. Now in the case when J0 and K1, in this case we get the present state 0, 1, and next state 0, 1, and in the case of J1, J0 and K1, then we get present state 1, 0, and next state 0, 1. So that state is known as a reset state. In the case of J1 and K0, then we get 0, 1 and 1, 0, and next state is set 1, 0. So that case is known as a set case. And in the case of J1 and K1, then in this case there is alter values 0, 1, 1, 0, 1, 0, and 0, 1. So that case is known as a toggle value or toggle state. Next flip-flop is D flip-flop. It is also known as a delay flip-flop. In this flip-flop, we also use the RS flip-flops combined with a single clock. That is the block diagram of the D flip-flop. The D flip-flop will store the output whatever logic level is applied to its data terminal so long as clock input is high. So once the clock goes high and we then set and reset, inputs of the flip-flop are both held at level 1. So it will not change state. Data was present on its output before the clock transition occurred. So in other words, we can say that output is latch at either logic value is 0 or 1. So using the concept of the D flip-flop, if our clock is low, it means 0, then any value of D, we always get the unchanged value. But in the case of high clock, then D value is 0, then we get Q0 and 1, and D value is 1, and in this case we get the value of Q1 and Q are 0. So that is the truth tables of the D. Now our next topics regarding to the combinational circuits is discussed in next class.